Hello class, in this video I will be introducing the pivot and how it is used to find a solution to the simplex tableau matrix. Let's begin. To obtain solutions to the tableau matrix, it is necessary to pick one non-zero entry as a pivot and create zeros in all other entries in that column. For this example, the pivot is the 6 in the first row, second column. In the next section, we will discuss how to find the pivot. All right, so the directions state, pivot about the indicated 6 of the following initial simplex tableau matrix. Then read the solution. Okay, so in this current form, x1 equals x2 equals x3, and they all equal 0 because they are non-basic variables. To make one of those variables basic, we're going to have to create a column where there's only one non-zero entry. And in this problem, we've indicated that the 6 that's in blue is the pivot. So what we're going to do is we're going to make this 5 a 0. Then we're going to make this 6 a 0. Then we're going to make this negative 50 a 0, all using row operations. So let's start by making the highlighted 5 a 0. And we can do that using the row operation. Negative 5, row 1, plus 6, row 2, is a new row 2. To make the 6 that is highlighted in pink a 0, we can use R1 minus R3. And that is a new row 3. To make the negative 50 a 0, we can use 50 row 1 plus 6 row 4, and that's going to be a new row 4. Now what's really important about these row operations is that each one of them has the row in which the pivot is located. So each row operation must contain the row in which the pivot lies. Okay, so now that we have all of the row operations, I am going to write the simplex tableau matrix as if the arithmetic has already been done. So the first row doesn't change. That's still 3, 6, 2, 1, 0, 0, 0, 60. And if we applied the row operation in red, we would have the following. After applying the row operation in pink, we would have the following. And after applying the row operation in blue, this would be the last row. Okay, so now that we've applied all the row operations, we need to look at this last column and see if there are any negative numbers there. And there are. There is a negative 120. So what I'm going to do is I'm going to multiply the third row by negative 1. And I'm just going to make some space here so we can fit the rest of the problem. So I'm going to go ahead and multiply the third row by negative 1, and that will give us the following. Okay. And now that we have pivoted about the 6 that was in blue, notice that the variable x2 is now a basic variable. The variable s2 is basic, so is s3, so is z. The non-basic variables are x1, x3, and s1. So the solution is the following. We know that x sub 1 is equal to x sub 3, which is equal to s sub 1, and they all equal 0. Because those are the non-basic variables. For the other variables, x2 is equal to the following. It is equal to 60 divided by 6, which is 10. S sub 2 is equal to 180 divided by 6. So S sub 2 is equal to 180 divided by 6, which is equal to 30. S sub 3 is equal to 120 divided by 1. So S sub 3 is 120. And Z is equal to 3,000 divided by 6, which happens to be 500. So this is a solution to the initial simplex tableau matrix. It may not be the most ideal solution, but it is indeed a solution.